Hello all, today we are going to start Unit 5 Remote Method Invocation RMI. First, what is RMI? The Java Remote Method Invocation, that is Java RMI, is a Java API that performs the object-oriented equivalent of remote procedure calls, that is RPC, with support for a direct transfer of serialized Java classes and distributed garbage collection. Remote method invocation, that is RMI, can also be seen as the process of activating a method on a remotely running object. RMI offers location transparency because a user feels that a method is executed on a locally running object. The remote method invocation is a Java API that is used to create distributed application and allows for remote communication between Java programs. It included in the java.rmi package. RMI stands for the remote method invocation. It is a mechanism that allows an object residing in one system, that is JVM, to access or invoke an object running on another JPO. Then next is Rmi Application Architecture. In an Rmi application, we write two programs. A server program resides on the server and a client program that is reside on a client. Two programs can be built in an Rmi application. Nothing but a server program and a client program. Inside a server program, a remote object is created and reference of that object is made available for the client using the registry. The client program requests the remote objects on the server and tries to invoke its method. The following diagram shows the architecture of Rmi application. It consists of various components like a transport layer, stub, skeleton, server, and RRL. We discuss one by one in detail. First component is transport layer. This layer establishes a connection between the client and the server. It maintains the current connections and establishes new connections or new ones connection. Then next component is stub. A stub is a client-side representation of the remote object. It is a gateway for the client software that sits in the client system. The stub is an object that serves as a client-side gateway. It is via which all outbound requests are directed. It is a client-side object that represents a remote object. It acts as a gateway for the client program. The caller does the following duties when the calling a method on the stub object. That is, it establishes a connection with the remote virtual machine, nothing but JVM. It writes and transmits the parameter to the remote virtual machine, that is JVM, and it awaits the outcome. It then reads or unmarshals the return value or the exception and then return the value to the caller. It performs this type of duties. Next component is skeleton. This is the object that is stored on the server side. Stub communicates with this skeleton to pass the request to the remote object. The skeleton is a server-side object that serves as a gateway. It is where all inbound requests are routed. When the skeleton receives a request, it performs the action. First action, it reads the remote method's parameter. Second one, it calls the method on the actual distance object. And third one is, it writes and sends the result to the caller, that is marshal. The next component is RRL, nothing but remote reference layer. It is the layer which manages the reference made by the client to the remote object. This is all about the Rmi architecture. Then next topic is working of an Rmi application. The following are the items that perform the operations of an Rmi application. When the client makes a call to the remote object, it is received by the stub, which eventually passes this request to the RRL. When the client-side RRL receives the request, it invokes a method called invoke of the object remote reference. It passes the request to the RRL on the server side. The RRL on the server side passes the request to the skeleton, that is proxy on the server, which finally invokes the required object on the server. The result is passed all the way back to the client. This is the working of the RRI application, or RRI application is work in this way. Then next topic is marshalling and unmarshalling. Whenever a client invokes a method that accepts the parameter on the remote object, the parameters are bundled into a message before being sent over the network. This parameter may be of primitive type or object. In case of primitive type, the parameters are put together and a header is attached to it. In case the parameters are objects, then they are serialized. This process is known as marshalling. At the server side, the pack parameters are unbundled and then the required method is invoked. This process is known as a unmarshalling. When using a primitive type, the parameters are combined and the header is added. Objects are serialized. If the parameter or objects, marshalling is the term for this procedure. While the pack parameters are unbundled on a server and the required procedure is then invoked, then the unmarshalling is the term for this procedure. This is all about the marshalling and unmarshalling. Then next topic is Rmi registry. Rmi registry is the namespace on which all the server objects are placed. Each time the server creates an object, it registers this object with the Rmi registry, that is using bind or rebind method. These are the registered using a unique name known as bind name. To invoke a remote object, the client needs the reference of that object. At that time, the client fetches the object from the registry using its bind name, that is using lookup method. The following is the illustration that explains the entire process. That is, from Rmi registry, it fetches the object from the registry using the lookup. Then on a server side, it binds the object in the registry using rebind. This is all about the Rmi registry. There are two important sides for the Rmi registry, is nothing but client side and server side. Then what are the goals of Rmi? First one, to minimize the complexity of the application. Second one, to preserve the type safety. Third one, distributed garbage collection. And fourth one, minimize the difference between working with a local and remote object. These are all the goals of the Rmi. Next, Rmi Programming Model. Then the next topic is Rmi Programming Model. There are 6 steps for writing the Rmi program. First one, create the remote interface. Second one, provide the implementation of the remote interface. Third one, compile the implementation class and create the stuff and skeleton object using the RMIC tool. Fourth one, start the registry service by Rmi registry tool. Fifth one, create and start the remote application. And sixth one is create and start the client application. These are the 6 important steps for writing the Rmi program. Next, let us consider the Rmi example. In this example, we have followed all the 6 steps to create and run the Rmi application. The client application needs only 2 files, remote interface and client application. In the Rmi application, both client and server interact with the remote interface. The client application invokes the method on the proxy object. Rmi sends the request to the remote JVM. The return value is sent back to the proxy object and then to the client application. In short, only 2 files are required for the client application. That is, first one remote interface and second one client program. The remote interface is used by both the client and the server in the Rmi application. The client application call proxy object method and the Rmi forward the request to the remote JVM. The return value is returned to the proxy object which is subsequently passed on to the client application. This is all about the Rmi programming model. The figure shows the Rmi programming model. We have already discussed the working of the Rmi model or Rmi programming model. Then first step is create the remote interface. For creating the remote interface, extend the remote interface and declare the remote exception with all the methods of the remote interface. Here we are creating a remote interface that extend the remote interface. There is only one method name add and it declares the remote exception. Let us consider the program. Import java.rmi public interface adder extend remote contain public int add int x int y throws remote exception curly bracket complete. These are the program that represents how we can create the remote interface. Then second step is provide the implementation of remote interface. Now we provide the implementation of the remote interface. For providing the implementation of the remote interface, we need to either extend the unicast remote object class or use the export object method of the unicast remote object class. In case you extend the unicast remote object class, you must define the constructor that declares the remote exception. Let us consider the program. On that program we can understand how we can create how we can provide the implementation of the remote interface. That is, import java.rmi, import java.rmi server public class adder remote extend unique class remote object implements adder remote throws remote exception super public int add int x int y return x plus y. This program represents how we can provide the implementation of the remote interface. Then third step is how we can create the stub and skeleton object using the Rmi tool. Next step is to create stub and skeleton object using the Rmi compiler. The Rmi tool invoke the Rmi compiler and create the stub and skeleton object. Let us consider the syntax that is used to represent how we can create the stub and skeleton object using the Rmi tool. That is Rmi addition remote. This is the syntax used to create the stub and skeleton object using the Rmi tool. Then next step is fourth step is start the registry service by the Rmi registry tool. Then now start the registry service by using the Rmi registry tool. If you don't specify the port number, it uses a default port number. In this example, we are using the port number 5000. Then let us consider the syntax how we can use or how we can start the registry service by using the Rmi registry tool. That is Rmi registry 2000 or Rmi registry 5000. We use port number, according to that we can use the syntax. Then next step, fifth number step is create and run the server application. Then how we can create and run the server application in Rmi application or Rmi registry is Rmi service must now run as a server process. The naming class has a method for retrieving and storing the distant objects. There are 5 methods in the naming class. In this case, we are using the name Sonu. Let us consider the program or the example that represent how we can create and run the server application. That is import java.rmi, import java.rmi registry, public class my server, public static void main, string args try, adder stub is equal to new adder remote, naming.rebind, rmi local host 5000 sonu stub, catch exception is system out.println. In this way, how we can create and run the server application with according to the name by using the any type of remote object of name. Then 6th number step is how we can create and run the client application. At the client, we are getting the stub object, or we use the naming class lookup method to fetch a stub object and then call the function on it. In this example, we are running the server and client application in the same machine, so we are using the local host. If you want to access the remote object from another machine, change the local host to the host name or IP address where the remote object is located. Let us consider the example, that is import java.rmi public class my client public static void main string asks try adder stub adder naming lookup rmi dot local host 500 sunu system out dot print ln stub dot add 34,4 catch exception e curly bracket complete. For running this Rmi example, first we compile all the Java files, that is java.java. Then second one, create the stub and skeleton object by RMIC tool, that is RMIC addition remote. Then third step is start the server in the another command prompt, that is Java demo server. And fifth one, start the client application in another command prompt, that is Java demo client or Java my client. These are the example. This example follows the steps we had discussed earlier. So thank you guys.